Hey team, today we're going over a few properties: parallelograms, rhombus, and rectangle properties. So we're going to start with parallelograms. There are 5 characteristics that parallelograms have. So the first one is opposite sides are parallel. And that's the definition, that both pairs of opposite sides, hey, they have to be parallel. That makes it a parallelogram. The second one, opposite sides are congruent. And so they're the same length, they're equal sizes, they're equal measurements, and they would be congruent. The third characteristic, opposite angles are congruent. And so the angles across from each other, they would have the same measurement, they're the same size, anything like that. And the fourth characteristic, consecutive angles are supplementary. And so whenever you see the word supplementary, hey, think that that adds up to 180 degrees. Complementary would be 90, supplementary would be 180. And the fifth characteristic of parallelograms, diagonals bisect each other. Alright, so the first one, since that is a definition, we don't really have an example of that. All these would hold that definition that the opposite sides are parallel. So let's go on to, and we'll do an example of one of each of these. So we're going over the first property here. Well, the first one was a definition, so we're going to look at the property or the characteristic of opposite sides are congruent. So we have a parallelogram here, and let's give it a name. Let's say we're going to call this parallelogram Jake. So here's Jake. Alright, parallelogram Jake. Let's say the top side had a length or a measurement of 22, and the bottom line was 4x plus 2. And we'll keep all the examples basic just so we can see the characteristic. And so, based on the characteristic we had above, we'd have 4x. Well, if they're congruent, that means they're equal in measurement, so 4x plus 2 would equal 22. And then we have our equation set up, so we'd subtract 2 on both sides. Okay, so we have 4x equaling 20, and opposite of multiplying would be dividing, so divide a 4 on both sides, x would equal 5. Alright, let's look at the third property. So opposite angles are congruent. So here we have another parallelogram. Let's move it on over, and we're going to call this one Sean. Alright, S-E-A-N. Different way to spell Sean, okay. And so we're looking at opposite angles are congruent, so let's say in this corner we had 6x plus 6, and in the top right corner we had 5x plus 15. Okay. And so, well, they look like the same length, well, hey, they actually are, so we'd have 6x plus 6 is equal to 5x plus 15. And then we have a nice equation here, and so you have a couple options of how to start it. I usually start with the numbers first, getting those to one side, so I'll subtract 6 on both, leaving you with 6x on the left and 5x plus 9 on the right, and then subtract 5x on both sides, leaving you with 1x equaling 9. You usually don't have to divide. This time we got lucky, we don't have to. Alright, on to the next one. Let's look at an example for consecutive angles being supplementary. So let's zoom down a little. Here's another parallelogram of ours. And so we're going to look at consecutive angles being supplementary. Let's call this rectangle, or sorry, parallelogram Tori. Alright, so on the bottom left, let's say this was 71x minus 1, and the top was 1 plus 109x. And so this time they're not equal to each other, and just looking at the length, we have an obtuse angle and an acute angle. No way those are going to be the same. However, we do know they are supplementary. So we have 71x minus 1. Instead of writing equals, you're going to write plus 1 plus 109x. And all of this will be equal to 180. Alright, so to solve this, we combine our like terms on the left side first. So negative 1 plus a 1 would be nothing. And 71x plus 109x would be 180x. equals 180, and a lot of things cancel here. Hey, it looks like x is going to equal 1 in this example. Alright, and the fifth characteristic, diagonals bisect each other. So one more parallelogram here. And let's draw our diagonals first. So this would be a diagonal, and from this corner to the other opposite corner, that'd be a diagonal. Alright, let's call this one Jackie. So we have J-A-C-K, and we'll go with a Y. And so diagonals bisect each other. So if we had this line, JC, be 6x plus 1, and then CY right here would be 4x plus 9. Well, since these bisect each other, that means that this is the same length as this line right here. Therefore, we can set them equal to each other. So we have 6x plus 1 equals 4x plus 9. Then I usually start with the numbers, so we'll subtract 1 on both sides. Leaving you with 6x equaling 4x plus 8. And then subtract 4x on both sides. Leaving me with 2x equals 8. And divide the 2, x will equal 4. Alright, so a rhombus has every single property that a parallelogram has, plus these extra ones. So here they are. All sides are congruent. So not just the opposite sides, all sides are congruent. The second property, diagonals bisect the angles. And the third property of a rhombus is diagonals are perpendicular bisectors. Okay, and so let's look at an example for each of these. So let's say we had a rhombus. Let's see, so kind of like a diamond shape. Close, not quite a rhombus. We'll assume it is with our markings. And so over here, let's say we had x plus 14. And over here we had 2y plus 4. In the bottom line we had xy minus 3. And the bottom left line we had 5x minus 2. Okay, let's call this rhombus Alex. So ax will be 5x minus 2, and so on. Okay, well, it looks like we have these lines right next to each other, and we want to solve for x, we want to solve for y in this example, and we have to use the fact that all sides are congruent. So that means this would be the same length as this line over here, ax would be the same length as xe, xe would be the same length as le. That's going to be useful because, hey, here we have just the variable x. If I try to solve for y first, well, I'd get stuck because I don't know x right here, so I wouldn't be able to solve it. So let's go ahead and solve for x first, and then we can substitute that in. And so here we'd have x plus 14 would be equal to 5x minus 2. And so let's see, let's start with our numbers, add 2 to both sides. Leaving you with 5x equaling x plus 16. Subtract x from both sides, and you'd have 16 equals 4x. Hey, leaving you with x equaling 4. So that's useful because you're going to plug it in right here when you solve for y. So you have the same setup for your y's. 2y plus 4 would be equal to xy minus 3, and we know this value now, so we'll substitute that in. So we have 2y plus 4 equals 4y minus 3. And now we can solve it. So we'll subtract 2y on both sides. And start with the variables this time, mix it up. Leaving you with 4 on the left, 2y minus 3 on the right. Add 3 to both sides. Leaving you with 7 equaling 2y. And so y would equal 7/2 or 3.5. Okay, let's look at the second fact, characteristic diagonals bisect the angles. Let's check it out. So let's have another rhombus. A slightly better rhombus this time. And we're going to call this one Fran. Alright, so we had a diagonal extended from the corner to the opposite corner. And in this top right corner, we'd have the value of 3x minus 2. In the other side of it, let's say we had a value of 2x plus 16. And so that expression would be in top left, this one would be in the top right. Well, the diagonals bisect the angles, therefore bisections, they're equal to each other, so this would be equal to this one right there. And so 2x plus 16 is equal to 3x minus 2. And so now we're able to solve it. So let's add 2 to both sides. Leaving you with 2x plus 18 equals 3x. And then subtract our 2x. Leaving you with 18 equals 1x. And hey, you solve for x. That problem is done. You found the value. Alright, and the third characteristic we said it was diagonals are perpendicular bisectors. Okay. So let's look at that property. So there we have, let's say we had a rhombus, and we'll draw the diagonals. Okay. And we know this angle to be 70 degrees. Let's say we had to find, here, let's call this one James. So M right there, ES. Alright, so let's find angle 3, let's find, well, let's make 1 and 2 first. Let's find angle 1, angle 2, angle 3, and let's say angle 4 is right here. So we have to find the length of all those angles. Well, looking at our characteristic, diagonals bisect each other, or diagonals are perpendicular bisectors. That means every angle in here would be 90 degrees. So right away, you know angle 2 would be equal to 90 degrees. Okay, well, let's make a list. We have angle 1, angle 2, angle 3, and angle 4. And so if that's 90 degrees, that means there's 90 degrees here, which means 90 and 70 together are 160. And notice how we made 4 triangles. There are 180 degrees in a triangle. So 90 and 70 together is 160, leaving you with 20 for the smallest angle here. So that means angle 3 would have to be the same thing as our given angle, which would be 70. Angle 1 would be 20 degrees, and angle 4 would be that exact same thing, 20 degrees. Alright, those are the properties of a rhombus. Let's take a look at. So, rectangle has all the properties that a parallelogram has. It does not have the properties a rhombus has, but it has all the properties a parallelogram has, plus 2 additional ones. Here they are. So the first one, all angles are right angles by definition. And so when that happens, hey, we call it a rectangle because that's the definition of it. The second property, diagonals are congruent. And so we have the 5 properties of a parallelogram plus those 2 for a rectangle. Let's go ahead and look at these 2. The first one, let's go ahead and draw it. So we have a rectangle here. And let's draw at least one diagonal in this one. So this portion of the angle, we'll just say it's x plus 2. And the portion down here is 4x minus 12. Well, by definition, all angles are right angles in a rectangle. So if we are given a rectangle, that means this corner would have to be 90 degrees. Therefore, these are complementary. So we have a setup being 4x minus 12 plus x plus 2. would have to add up to 90 degrees. So let's go ahead and combine our like terms. So negative 12 plus a 2 would leave us with negative 10. 4x plus x would give us 5x, and all of that would still equal 90. Okay, and then let's see, add 10 to both sides. And so you'd have 5x equals 100, and divide your 5, looks like x is going to equal 20. Okay, so let's look at the other one. Diagonals are congruent. So let's draw another rectangle. Here we go. And so let's draw our diagonals in. And so let's say right here we had this diagonal would be the length of 9x minus 9. And the diagonal here would be 7x plus 1. So 9x minus 9, and then 7x plus 1. So in a parallelogram, we had the angle or diagonals bisect each other. In a rectangle, the diagonals are congruent, so this is the same length as this whole diagonal. It also contains the properties of the parallelogram, meaning they bisect each other, therefore these are going to be congruent. So our setup would be 9x minus 9 is equal to 7x plus 1. And then let's go ahead and add 9 to both sides. Leaving me with 9x equaling 7x plus 10. Subtract 7x to both sides. So 2x equals 10. Looks like x will equal 5. Alright. And a parallelogram, a rhombus, and a rectangle together would give you a square. And so if you were given a square, any of these examples would apply if you were given a square. So we don't need to do an example of a square because technically you do every single setup that we did, and that would apply in a square. Hope this helps. Thanks for watching.